Today, we will be covering SQL ranking functions. So these functions allow you to rank or order rows within a data set or within a partition of a data set. And they have numerous applications if you're trying to create a ranked leaderboard or trying to do some performance comparisons that involve rankings. These ranking functions come in very handy. So there are basically three functions that we'll be talking about today. So one is the rank, the second is the dense rank, and the third is the row number. So these are all window functions that allow you to rank data sets in different ways. So let me just quickly go over the difference. So rank is probably the most common, I would say. This is when you're trying to rank rows, but you want to skip the rankings for ties. So for example, 1, 2, 2, and then 4. So since you have two rows that are tied at 2, you're going to skip number 3, and then you're going to go straight to 4. Dense rank is very similar to rank, but it does not skip rankings for ties. So even if you have a tie, let's say you have 1, 2, 2, the next number will still be 3. It will still be the next number in the sequence, irregardless of how many kind of ties that you have in between. So if you're looking at something like a leaderboard, for example, rank might be more useful than dense rank. But if you're trying to rank something without gaps, then dense rank is definitely the way to go. And then the third one is row number. So row number is a bit different from rank and dense rank. In this one, you're basically assigning a unique sequential number to each row. So this is somewhat like assigning a unique kind of ID to each row. Even if the values are tied, this will still be 1, 2, 3, 4, and so on. Now let's dive in to see an example for each. So let's first take a look at the data set that we have. We have here 3 columns of data. We have month, product, and orders. So this is basically the number of orders for each product for each month from 1 to 12. So that's January to December, where 1 corresponds to January and 12 corresponds to December. So what we have to do in this example is to write a query to rank the data by orders and then skip numbers after ties. So that means we will be using rank since we have to skip the numbers after the ties. If we just write a query to select all from the table, and let me run this, this is what I'll get. So I'm going to get the raw data here. So this is each month, product, and the number of orders. So what we will now do is modify this query to add the ranking. So I'm going to first list down the existing column. So that's month, product, orders. And then I'm going to write the ranking function. So this will be rank over order by orders. So I want to rank this table by orders, and I want the most number of orders to be ranked as 1. So I will add descending here, meaning it will rank the orders in a descending order. And then I will save this as ranking, and then I will write the from statement, product, order, count by month, and that should do it. So let me try running this. And there you go. So you can see that it has added a new column called ranking, where the row with the most number of orders is ranked 1, and so on. And you can also see that it has skipped ranking after ties. So you have 2 rows here that are tied at number 4. And so after that, it assigned a rank of 6 instead of 5. So it basically skipped a number, and that is because we used the function rank. So in the same way, if I use dense rank instead of rank, we can see in this example where I have dense rank. Let me just run this. You can see that it's basically the same output, but what it has done is it has continued along the sequence, and it hasn't skipped a number after the tied ranking here. So after 4, 4, instead of 6, it continues on to 5, and then 6 again here is tied. It continues on to 7, and so on. So that is basically the difference between rank and dense rank. Dense rank is, as the name suggests, basically a more condensed ranking where it doesn't skip any numbers. So the next thing I want to show you is another example using rank, but this time within a partition of a data set. So in this example, let's say we wanted to write a query to rank the data by orders for each product. How would we do that? So what we did in our original example is basically ranked the entire table by orders descending and assigned a rank to each row. But then what we want to do now is within each product, create kind of a sub-ranking within each product so that it shows us the ranking for that product and then kind of resets for each new product. So the way to do this is basically by adding a partition function here. So you can do partition by product. Since we want to kind of categorize or rank the data by products, we can do partition by product, and then everything else stays the same. So the only new thing that we added here is this clause over here, partition by product. So now if I run this, you will notice a difference where it still ranked the rows, but then it kind of arranged the data by product. So we have bold black T here, and then we have the ranking from 1 to 12. And then for the new product, which is this velvety vanilla latte, the ranking kind of reset, right? So that's what this partition function does. It basically splits or partitions the data into each product, and then within that partition does the ranking. So obviously you could still use dense rank and then do the same thing, partition by product and then order by orders. I would say when working with kind of real world data, it's very seldom for you to use these ranking functions without the partition. More often than not, you will be needing to kind of categorize or split the data and then do your ranking within that dimension. So that should basically be it for rank and dense rank. Now let's move over to row number. Row number is a bit different from rank and dense rank. It's basically just adding a row number, as the name suggests, to your data. So in this example, we're going to write a query to add a new column that provides a unique row ID for each row. So this is the data that we have, same data set where we have month, product, and orders. So what we're going to do is basically add a new column to provide a unique row ID. So we're going to modify this query to first list down the existing columns that we need to output. So that's month, product, and orders. And then I will add up here in the first column our row ID. So the way to do this is to use the row number window function and then over order by month. So I will just order this based on its existing kind of order that the table has. So as you can see, the table is sorted by month by default. So we will continue to order it by month. And then I will call this row underscore n. So let us try running this query. Whoops, we have an error over here. I think we just forgot a comma. So let's try running that again. And there you have it. So what this did is basically add a new column, row underscore n. And as you can see, it added a row number to each row of the data. Now, we could also similarly partition this as we did with the rank. So that would look something like this, where we basically add this clause, partition by product. And by adding this, what the row number will do is kind of order the data by product and assign a row number within that product for each row. So 1 until 12. And then for every new product, it's going to kind of reset and go back to 1 and then order all the rows within that product from 1 to 12 again. So that is how you use partition with the row number. So that's basically it. What we covered in this video was rank, dense rank, and row number. These are kind of the three main ranking functions in SQL. And I hope you found this video helpful. Don't forget to like and subscribe.